17.1, we have a problem here that gives you 2 points, and it also gives you 2 different problems. And for here, we're just going to substitute. So we're going to plug the 1 into the x. It becomes 3 times 1 equals 2 minus -1. So we'll work this problem out first. So we'll do the multiplication. 3 times 1 is 3. And you'll bring 2 minus -1 down. And because you're subtracting by a negative, you would have to change the signs. So this becomes 2 plus +1. Basically 2 plus 1 equals 3. So both sides equal to each other. That checks out. You can do the same thing over here. Plug in the x point and the y point. So it becomes 4 times 1 equals 7 plus 3 times -1. So do the multiplication first. 4 times 1 equals 4. Then 7. 3 times -1 is a -3, so it'll become 7 minus 3. And you just do the subtraction there, and it'll become 4. Both sides are equal, and that also checks out. So this is an ordered pair, the solution. So you would write yes.
This is 15.2.7. Solve the following system by the substitution method and check the solution. What we have here is equation 1 and equation 2, which is 7x plus 2y equals 82, and x equals y plus 4. Since x is solved on equation 2, we're gonna put it to equation 1, so it was gonna look like x plus 1 equals 82, and it's gonna look like this. So y plus 4 plus 2y equals 82. We're gonna use the distribution property. So what that means is this 7 is gonna go to y plus 4, and 7 plus y equals 7y. 7 times 4 will equal to 28, plus 2y equals 82. And now we're gonna combine like terms. The only like terms we see right now are the 7y and the 2y. So 7 plus 2, that would give us 9y plus 28 equals 82. Now we're going to try to find y alone. So we're going to substitute the 28 on both sides. 82 minus 28 would give us 54. And we're gonna divide by 9, and our y would give us 6. That is our y, and now we're gonna solve for x. So we're gonna use our second equation, x equals y plus 4, and our y is 6. So x equals 6 plus 4, and 6 plus 4 equals 10, so x is actually 10. But now we have to check our solution, so we're gonna put the x, which is equals to 10, and our y, which is equals to 6, to our first equation. So we're gonna write it down, our first equation, 7 which is 7x plus 2y equals 82. 7 times 10 plus 2 times 6 equals, oh wait, let me just make it a little bit smaller. So now we're going to multiply everything. we're gonna solve for everything. So 7 times 10 would give us a 70, and 2 times 6 would give us a 12. And we're gonna write down our 82. And 70 plus 12, well, that one equals to 82 and 82. So this is actually correct. And we're gonna solve for equation 2 now. Just x equals y plus 4. Remember, our x is equals to 10 and our y is 6 plus 4. And all we have to do is solve for this and bring down our 10, and 6 plus 4 equals to 10. So this is correct too. And this is how you do the substitution method.
So we're going to work out 15.3, number 13. Use the elimination method to solve the following system of equations. So in this problem, you have equation 1 and 2. For the first equation, you have 5x plus y equals negative 13. Second equation is 7x minus 3y equals negative 49. So you're going to use the elimination method, and you want to choose a variable that you can eliminate easily. In this problem, you have y that looks easy to eliminate, so you rewrite the problem, and in order to eliminate y, you multiply 3 in the first equation. So it'll be 3 times 5x plus y equals negative 13. So you multiply 3 to the first equation, and it should give you 15x plus 3y equals negative 39. So you also want to rewrite your second equation, which is 7x minus 3y equals negative 49. In this problem now, you can eliminate y because positive 3 cannot add to negative 3. So you eliminate y. Now you can combine like terms, which is 15 plus 7 gives you 22x, and negative 39 minus 49 gives you negative 88. Now you have to find x, and in order to find x, you must divide 22 on both sides, and it'll give you x equals negative 4. Now you have to substitute x into the first equation to find y, which will give you, in your first equation, you have 5x, so x equals to negative 4 now. So it's 5 times negative 4 plus y equals negative 13. You combine like terms, 5 times negative 4 equals negative 20 plus y equals negative 13. And you combine like terms again, add 20 on both sides, and you're left with the y variable, and that'll give you negative 13 plus 20 equals 7. That is your answer.
So 15.4, number 37, we have a word problem. A cyclist began a 544-mile ride from one end, and a car travels towards it from the other end. If the bicycle and car met after 8.5 hours, and the car traveled 35.6 miles per hour faster, we're going to find the average rate of each. So the formula that we're going to use for this problem will be rate times time equals distance. Okay, so we're going to have two equations. So our first equation is going to be 8.5x plus 8.5y equals the total distance of 544. So that's our first equation. Our second equation is going to be x minus y equals 35.6, and that is the difference in rate. So next we're gonna solve the first equation. So we're gonna take 8.5x plus 8.5y equals 544. and we're going to divide each side by 8.5. So 8.5. So these two cancel out because they equal 1. Just add the y. And that'll leave you with x plus y equals, and 544 divided by 8.5 will give you 64. And this is our new first equation. So now we're going to take our new first equation and add it into the second equation. So we go over here, and that'll give you x plus y equals 64 plus x minus y equals 35.6. You add that up, x plus x gives you 2x. And because positive y and negative y, they're the same coefficient but different sign, so they cancel out. And that will just give you, and 64 plus 35.6 gives you 99.6. And because we're getting x alone, you're going to divide both sides by 2. So 2 cancels out. That leaves you with x equals 99.6 divided by 2 leaves you with 49.8. So that's one answer, and that's for the car. So since we found x, we're going to plug it into one of the two equations. So we're going to go with the second equation because it's easier to solve. So we take 49.8, which is our x, minus y equals 35.6. And because we're finding y, you're going to subtract both sides by 49.8. So that cancels out, and it leaves you with negative y equals 14.2. Because there's a negative y, we never want that to happen. So you just divide both sides by negative 1 because there's always an invisible 1. So that'll leave you with y equals, and negative 14.2 divided by negative 1 is positive 14.2. That will be for the bike.
Okay, so in our last problem, we have two different equations that are representing two different lines. So we don't like the way this looks, we're going to change it into the slope-intercept form, which is y equals mx plus b. So we're going to subtract 3x from both sides to get the y by itself. So it's going to be 5y is less than negative 3x plus 15. Because the y is still not by itself, we're going to divide 5 from both sides. So it's going to be y is less than negative 3 over 5x. Because 15 divided by 5 is 3, it's going to be plus 3. So that's the equation for your first line that's going to go on your graph. And same thing with the second equation for the second line. We need to get y by itself, so we're going to subtract 3x from both sides. Your new equation is going to be negative 4y is less than negative 3x plus 12. Then you need to divide negative 4 from both sides. And because they're dividing by a negative number, your sign is going to change directions. So it's going to be y is greater than 3 over 4. And that becomes positive because you have two negative numbers. So 3 over 4x minus, this is going to be a negative because you are dividing two different signs. So 12 divided by negative 4 is negative 3. So the second equation for the second line on the graph is y is greater than 3 over 4x minus 3. Okay, so now that you have your two new equations, you're just going to graph them. So because there is no equal to sign, it's just a less than or greater than sign, you're going to have dotted lines. So for the first equation, y is less than negative 3 over 5x plus 3. You're going to graph the y-intercept first, so it's going to be a positive 3 up here. And then you're going to go down 3 times because it's a negative 3. So 1, 2, 3. And then because it's a positive 5, we're going to go to the right 5 times. So 1, 2, 3, 4, 5. And then you'll draw your line through there. And then because it's y less than negative 3 over 5, you're just going to shade under that line. And then for your second line, you have y is greater than 3 over 4x minus 3. Just going to change colors. So you're going to graph the y-intercept, which is negative 3 down here. And then because it's a positive 3 over 4 for your slope, you're going to go up 3 times. So 1, 2, 3. And then to the right 4 times. 1, 2, 3, 4. And then you're going to draw your line through those 2 points. And then because it's y is greater than 3 over 4x minus 3, you're going to shade above this line. So your general answer is within this space, this area. For your final answer, you just want to shade where the answers share the same quadrants.